Acceleration of free fall. In the absence of air resistance, all objects fall with same acceleration. Acceleration of gravity is 9.8 meter per second square. This means that for every second an object falls, its velocity will increase by 9.8 meter per second. Sometimes this is also called as acceleration due to gravity. The symbol G stands for the gravitational field strength and can be used to calculate the weight of an object using its mass. Formula to calculate weight is written as weight is equal to mass multiplied by gravitational field strength. So W is equal to mg. Motion of falling object. Let's discuss falling object without air resistance. In the absence of air resistance, all objects falling in a uniform gravitational field fall with the same acceleration regardless of their mass. In this diagram, if ball and feather are made to fall in vacuum, both will fall with same acceleration. So long as air resistance remain insignificant, the speed of the falling object will increase at steady rate and gets larger as it keeps falling. Let us understand this with diagram. Here is negligible air resistance, so only force acting is weight. Thus we can say that, in the absence of air resistance, objects fall with constant acceleration. Next topic is falling object with air resistance. Objects falling through fluids like air or gases in a uniform gravitational field experience two forces. First is weight due to gravity. Second is friction due to air resistance. A skydiver jumping from a plane will experience a downward acting force of weight that is mass multiplied by acceleration of free fall. An upward acting force of air resistance. Frictional forces always oppose the direction of motion. This can be explained with the help of following figure. This is weight. There is larger resultant force. This is due to absence of air resistance. For second figure, air resistance starts to act. So there will be smaller resultant force. In third figure, as diver comes down, air resistance increases and becomes equal to weight. At this point, resultant force is zero, because air resistance equals weight. So skydiver falls with constant velocity or zero acceleration. This is called terminal velocity. Let us understand the graph showing how the velocity of a skydiver changes during the descent. This is velocity. And this is time. This is curve during the descent of diver. At first, the air resistance is small and person accelerates. In this part, as diver speeds up, so air resistance increases. In this part, after a while air resistance balances weight of diver and diver travels with constant terminal velocity. In this part, diver opens parachute. There is large upward force, which cause diver to decelerate. Eventually the forces balances once more and the person makes new but much slower terminal velocity.